I think we are live. So I'm going to go ahead and get started on the multiple choice. So our first question, we have this graph, and they give us the graph, they call it position graph, which you need to remember is basically, position graph is as if I had an f of x graph. It's the same as having that original graph. And then they say, for what values of t is the velocity increasing? Now, this is kind of a little bit of a double, because they're asking for velocity increasing. Okay, velocity, when I see the word increasing, means that v prime is positive. Another thing for v prime is positive is that a is positive. So I'm given, again, position, right? So if we have position, velocity, acceleration, acceleration is the second derivative. So if I want a positive acceleration, that means that position needs to be concave up. Right, so it's kind of like if I'm given f of x and they ask when is f prime of x, that would be velocity increasing. Well, remember, f prime of x increasing means f is concave up, right, or f double prime positive. So where is this graph concave up? And so they tell us we have horizontal tangents at 1 and 5, but a point of inflection at 2. That's what we need to know, that point of inflection. So that's our concave up spot from 0 to 2. Right, we have a particle moving along the x-axis, and again, position given by this function. At what time is the particle at rest? Anytime we see at rest, particle at rest, we always set v of t equal to 0. Whether we have v of t or whether we have position, we set v of t equal to 0. So to get v of t here, I need to take the derivative, right? Position, velocity, acceleration, that's 6t squared minus 41t plus 72. Equal 42t, there we go, equal to 0. And I can factor out a 6, that's t squared, minus 7t, and then this is plus 12, right? 66 times, 6 times 11 is 66, so 6 times 12 is 72. So I need two numbers that multiply to 12, add up to negative 7, that's negative 3 and negative 4. And so that gives us t equals 3 and 4. And they say, when is it at rest? So it's just those two. If it was moving to the left, I would make a number line. Moving to the right, I would make a number line. But just at rest, I don't need to do anything else. That's just the answer. All right. And if you have any questions on anything, just put them in the chat, and I will address them. The position of a particle moving along a straight line at any time t is given by S of t. What is the acceleration when time is 4 at time 4? So basically we want a of 4. So position, velocity, acceleration, I have position, so I need to take the derivative twice. So v of t would be 2t plus 4, and a of t is just 2. So a of anything, a of 4 or a of anything is just 2. Right, because you plug in 4 into 2, it's still 2. Okay, next one is an absolute maximum. Absolute maximum. If they just had said maximum, but they gave me an interval, it would have been an absolute maximum anyways. That's a good thing to remember. So in order to do an absolute maximum, that's kind of part of EVT, is we take the derivative and set it equal to 0. So the derivative here is 3x squared minus 6x. We're going to set that to 0. Factor out 3x. That gives me x minus 2 equals to 0. This part gives me x equals 0, and this part gives me x equals 2. So that's our first step. Then our second step is to make a table with x, and again, whatever I took the derivative of, whatever I want the maximum of. That's what goes over here on the right side of the table. Then I put my endpoints, negative 2 and positive 4, and any critical points that are within there. So I need to make sure that both of those are in between negative 2 and 4. They both are. So I'm going to include both of them. Now, they want the maximum value that occurs at x equals. So my answer, this is important, my answer is going to be one of these guys. It's not going to be what I get. So the only options are negative 2, 0, 2, and 4. I can immediately cross out C. So even if I somehow mess up somewhere, I know the answer is not C. So I'm going to just start plugging everything in. Negative 2 cubed minus 3 times negative 2 squared plus 12. That's negative 8 minus 3 times 4 plus 12. That's negative 8 and negative 12. Make negative 20 plus 12, which is negative 8. So it goes at negative 8. When I plug in 0, I get 12. When I plug in 2, that's 8 minus 3 times 2 squared is 4. So 3 times 4 is 12. Plus 12, those guys cancel. And my guess is it's going to be 4. 4 cubed is 64. Minus 3 times 4 squared is 16. Plus 12. This is 64 minus 48. Plus 12. I'm going to add the 64 and 12. That makes 76 minus 48. You'd actually stop here if you realize that this is bigger, right? But 28, that's my biggest thing. So the absolute maximum occurs at A. All right, let f be the function given by f of x equals x cubed minus 3x squared. What are the values of c that satisfy the mean value theorem? So you need, on these ones, you just do the mean value theorem. F prime of c equals f of b minus f of a over b minus a. That's my mean value theorem. So I'm going to take the derivative. That's that prime of c part. 3x squared minus 6x. If we want to call it c, we can. We don't really have to. That's going to equal f of 3 minus f of 0 over 3 minus 0. I like to kind of do f of 3 on the side. That's 27 minus 3 times 9, 27. So 27 minus 27 is 0. And f of 0 is 0. This is actually a Rolle's theorem one. So we get 3x squared minus 6x equals to 0 minus 0 over 3 would be 0 over 3, which is just 0. And we actually just solved this, right? 3x times x minus 2. And we got x equals 0 and x equals 2. Now, interestingly enough, they didn't put 0 and 2 as an answer choice. If they had put 0 and 2 as an answer choice, some of you guys might have picked that and gotten it wrong. But for mean value theorem, if they're saying what values satisfy MVT or Rolle's, they cannot be the endpoints. Okay, they cannot be the endpoints. So anything with 0 or 3, I can actually get rid of. And that actually, I didn't even have to solve anything here. So that's kind of funny. All right, a particle moves along the x-axis so that at any time t, its position is given by x of t equals t e to the negative 2 t. When is the particle at rest? We did one like this, but with a nice polynomial. This is the same concept, but now with a harder derivative to solve. So particle at rest, we're thinking v of t needs to equal 0. So v of t here, this is going to be a product rule. Right, I have t times e to the negative 2t. The derivative of t is 1. E to the negative 2t stays by itself. Then plus t stays alone, or original. And e to the negative 2t, this is a chain, times negative 2, right? E to the box times the derivative of the box. We're going to set that to 0. So I can see I can factor out an e to the negative 2t from both of these. That leaves me with 1 minus 2t, right? What I'm left with is the t times negative 2. That's equal to 0. This part, you can go ahead and try to solve it. E to the negative 2t equals 0. Take the ln of both sides. Realize that the ln of 0 doesn't exist. Or you can just start to remember that anytime on these questions, the e to the x part or the e to whatever part will always give no solution. So the only part that's actually giving me a solution is this part. 1 minus 2t equals to 0. Add the 2t over. Divide by 2. We get t equals 1/2. Okay, so this is just 1/2. If the position of a particle on the x-axis at time t is negative 5t squared, then the average velocity of the particle between 0 and 3. So we need to remember the formula for average velocity. So average velocity is equal to x of 3 minus x of 0 over 3 minus 0, right? Position at 3 minus position at 0 over 3 minus 0. So position at 3 is negative 5 times 3 squared. That's negative 5 times 9, negative 45. Minus 0 over 3. That's negative 45 over 3, which is negative 15. All right, we're cruising along so far. Next up, we have a particle moving along, and this time again, they're giving us position. And they want to know what is the velocity. So they want a velocity of the particle when the acceleration is 0. So they want the velocity at some time. I don't know what this time is yet, but the hint they gave me is that's when the acceleration is 0. So we need to be careful. We're going to plug in some number to the velocity, right? That's like a v of t at time equals something. But we're going to solve for when the acceleration is 0. So that requires the solving button or the graph. So I'm going to pop over to my calculator to help us out. And so the first thing I'm going to do is I'm going to take the derivative to get the velocity. So derivative with respect to time of negative 4 cosine of t minus control divide t squared over 2 plus time. Okay, so that's going to give me the velocity. Then I'm going to take the derivative of that velocity. So what I can do is I can go d dt, and then I put my cursor into this box, and I hit the up arrow, right? If I hit this up arrow, it highlights that guy. When I hit enter, it brings it down, and that's the second derivative. So this was the velocity. That's the acceleration. Now, I want to figure out when is this 0. Be careful. What I've seen a lot of students do is they highlight this, and then they do at time 0. This is not solving for when it's equal to 0. This would be totally wrong. This is plugging in 0. We didn't want to do that. We wanted to solve when is velocity equal to 0. So we need to set this equal to 0, not plug in 0. We're not putting t to 0. We're putting the whole thing to 0. So that's menu, algebra, solve. And then now I'm going to go up here, take this, equal it to 0, comma t. Now if I hit enter, I'm going to get something weird with ends. And that's because I didn't include the interval, right? This gave me an interval of 0 to pi, so we need to include that in our solve button. So I'm going to just come back up here, right? If we realize that ahead of time, that's great. If not, realize it once you get the ends. And then do control equals to at 0 less than t less than pi. You don't have to put less than or equal to. You don't need the endpoints. We get inverse cosine of 1/4. I'm going to hit control enter, and we get 1.318. If you do ever get a situation where you end up solving and you put in an interval and you still get an n1, the alternate method is to go ahead and graph it, right? So you can always graph it. You're never going to get that weird n1 business when you graph it. Okay, you're always going to get an answer when you graph it and use the 0 tool. So anyways, that was my answer for the t, but that wasn't what the question was asking. The question was asking, what is the velocity at this time? So I need to come back up here, right? The first derivative, this one was the velocity, and this is the one we're going to plug in at. And it's kind of nice when I use the solve button because I can just hit the up arrow and hit enter to bring that down. So 2.554, that's my answer for the velocity. All right, next up, the maximum acceleration attained on the interval, so this is an absolute max, of the particle's velocity is given by v of t is what? This one is a really tricky question. We really need to be careful that it's the maximum of the acceleration. So first I need to find the acceleration, which is 3t squared minus 6t plus 12. And a lot of students will set this equal to 0. But it's not. This is actually what I'm starting with, because I want the maximum of this. This was kind of a mean question. So I didn't want the maximum of the velocity, I want the maximum of this. So whatever I want to take the maximum of, that's what I'm then going to take the derivative of and set to 0. So I want to take a prime, right, essentially the jerk, and set that to 0. I solve, I get t equals to 1. So that's my critical point. And then to do a absolute maximum to figure out which one it is, I make this table. T, and then I said this is always what we want the maximum of. So it's the acceleration formula. So it's a of t. So we're actually not going to use this at all except to take the derivative to find the acceleration. Then I'm going to include my endpoints 0 and 3 and my critical point 1. And we plug these into the acceleration. So when I plug in 0, we get 12. When I plug in 1, 3 times 1 minus 6 times 1 is negative 3, plus 12 is 9. When I plug in 3, 3 times 3 squared is 27, minus 18, plus 12, and that's 21, which is the answer. So definitely a little bit of a tricky one, but something that I think is a really fun, interesting question that really tests if you can break down these. Next one, this is from a textbook that I used to use, and I really like this textbook, but I thought it was just a little bit too difficult, and so I switched over to what we have currently. Actually, both of these questions are from that textbook. So, suppose a particle is moving along a coordinate line, and its position at time t is given by s of t equals 9t squared over t squared plus 2. For what value of t in the interval 1 to 4 is the instantaneous velocity equal to the average velocity? So instantaneous velocity would be v of t or s prime of t. And the average velocity would be s of b, which in this case is 4, minus s of 1 equal to 4 minus 1. Right, so this is the derivative equal to the average. This is actually MVT. They didn't say it's MVT, but it is. And so you can do this entirely on your calculator. So I'm going to go ahead and do that. I'm going to grab my calculator. And I really like to, on this one, since I know I'm going to be using that a lot, I'm going to keep plugging in and referring to s of t. I'm going to just graph it. So I'm going to pop over to the graph, hit tab. We're going to delete everything. I feel like this is the fastest way to do this question. So I'm going to hit tab, and then we're going to do 9t squared divided by t squared plus 2. And I don't even care what the graph looks like. Oh, you know what? It asks a slider for t. That's my fault. Make these x's. Make these x's. Because when we're graphing it, we just change our t's to x's. So then we're going to come back over here, and I'm just going to do it right away. I'm going to go to Menu, Algebra, Solve, because I have an equal sign, right? If I have an equal sign, I'm trying to solve for t. I do that. The left side was s prime of t. Well, my t is f1. So s prime is the derivative. Now, instead of t, I'm using x. So I'm going to go the derivative with respect to x. And then I just type in f. When I type in f1, it turns bold, but I need to do parentheses of x. Then outside that derivative, it was equal to. I'm going to do control divide. S1 of 4, which is, sorry, S of 4, which is F1 of 4, minus, oops, jumped ahead, S of 1, in this case f1 of 1, over 4 minus 1. And then I'm not solving for t here because I used x, so comma x. And I get 0.192 or 2.2. And I have two answers. I'm like, wait, why do I have two answers? It's because I didn't put in the interval, which they only wanted answers that were between 1 and 4. So I could add that 1 less than x less than 4, or I could have just figured it out on my own, right? And I get 2.22 immediately. So to me, that's the absolute fastest way to do this question. Right, now, you could have definitely done it, a much longer way, which would have been to type it out, step by step. And I've seen a lot of you do that. As long as you get the right answer, I don't care how you do it. So you could have done it with t's, d dt, right? Control divide, t squared over 9t squared over t squared plus 2. I'm just showing this because a lot of you might do it this way, and you get that derivative. So then you might even just write on your paper, okay, we have the s prime of t part gives 36t over t squared plus 2 squared. And you write that down, and then you put equals to. And you do the next part on your calculator, which would be, I would first come up to here, just being a little bit more efficient. Hold shift, hit enter, and you plug this in at time 4, you get 8, then you go up, plug it in at time 1, you get 3, and then you can do a control divide, 8 minus 3 over 4 minus 1, and you get 5/3. So we'd come back over here to where we have our equation, and we do it, right? This is equal to 5/3. Now again, what I said is whenever I have this equal sign, that's the solve button. So I'm going to go back to my calculator and go to menu, algebra, solve, and then I can just pop way up here, grab this guy, get equals to, go up 5/3, comma t, and again that control at 1 less than t less than 4, and I get the same answer. To me, it's a lot more work, but it might be the way that you naturally think about, and so I wanted to show that as well. All right, next up, the function g of x equals x minus 2 times x minus 3 over x minus 1 does not satisfy the hypothesis of Rolle's theorem on the interval because. So when it says it doesn't satisfy Rolle's theorem, we need to think about what were the conditions for Rolle's theorem. First, in this case, it's g of x needed to be continuous. Secondly, g of x needs to be differentiable. And thirdly, g of, in this case, -3 needs to equal g of 2. Now, this is a rational expression, and for rationals, the denominator, if we set to 0, or can't be 0, right? So x cannot be 1 is my domain. Now, 1 is in this interval. So that means that we're not continuous at x equals 1. So the answer is C. G of x is not continuous on -3 to 2. 832, if the number defined by Rolle's theorem, if C is the number defined by Rolle's theorem, then for r of x equals 2x cubed minus 6x squared, on the interval from 0 to rad 3, C must be. So if they're asking me for what is C, with Rolle's theorem, all I have to do is take the derivative, set it to 0, and solve. So in this case, the derivative, r prime of x, is 6x squared minus 6, set it to 0, and solve. I don't need to worry about this 0 to rad 3 yet. Okay, so I'm going to add 6 over, divide by 6. We get x squared equals to 1. Square root both sides. I get x equals plus or minus 1. Now, this is where I'm going to worry about the interval. I need to think about, is positive 1 inside that interval? Yes, it is. Is negative 1 in that interval? No, it's not. So C is wrong because negative 1 was not in my interval. The answer is just positive 1. And this next one, which of the following statements are true of this graph? Before I do that, let me answer Nayeli's question. I just saw that why C and not D. I'm guessing we're talking about this one up here, Naeli, 825. So D is saying g of 0 does not equal to 0. We don't care if g of 0 equals 0. Rolle's theorem says g prime of 0 must equal 0 somewhere. But that's the result. Okay, this is the result. If they're saying that Rolle's theorem does not apply, right? This function does not satisfy Rolle's theorem. That's basically saying that Rolle's doesn't apply. We can't apply it because one of these three conditions doesn't work. So you always kind of go in order, right? And first you want to check, is g of x continuous? And so that will take precedence. So g of x is not continuous, that's my answer. If it was continuous, then you would move on and check if it was differentiable. If it was differentiable, then you would plug in the endpoints and make sure that those are equal. All three of those had to be true. But g of 0 equals to 0 for D, this is not one of my conditions. We don't care if g is 0. The result would be that if all three of those were true, right? If all three of these were true, the result would be g prime of something would be 0. But as soon as I actually see g of 0 is not 0, I know that's totally wrong. Right, g of 0 isn't even an endpoint. It's nothing we care about. So hopefully that answered your question. I'm not sure if you were talking about why is B not correct as well, because this is one sometimes students want to pick. But like I said, just go in order. G of x needs to be continuous first, then g of x needs to be differentiable, and then the endpoints need to equal each other. Those are the conditions. All right, let me know if that didn't answer your question, if it was something a little bit different, and I can go back to it. Okay, 834. Which of the following statements are, okay, how can we check if it was differentiable? Yeah, and then Jimena, yeah, so a good question, yeah. So if it's not continuous, it is also not differentiable. So you guys are totally right that B kind of seems like it might be a good answer as well. And technically, if you said Rolle's theorem doesn't apply because g of x is not differentiable, technically you would be right. But you always want to do the continuous part first, because remember, for differentiability, there's kind of a few cases. We have our corners are not differentiable. We have any kinks or cusps. Right, all of these spots are not differentiable. And then we also have our vertical tangent lines. Are not differentiable. So all three of those are not differentiable. But all three of these are also continuous. Okay, so those are differentiable and continuous. Now, the fourth differentiable, like where we're not differentiable, I guess. The fourth one is when we're not differentiable because the graph wasn't continuous. Okay, and that's something like where maybe we have a hole, and so it can't be differentiable because we had a gap. Or maybe we had a vertical asymptote, and it's not continuous because of the vertical asymptote. Whatever type of discontinuity it was, it could have just been a hole, not even a jump. It's not differentiable. But the reasoning was because it wasn't continuous. It wasn't because we had a corner, a cusp, a vertical tangent. It was because it wasn't continuous. So this is like basically the first or the main reason that we are not differentiable, is because it wasn't continuous. So when we're checking for this Rolle's theorem, we just go in order, right? The first thing you check is, and that's why I always write it this way in this order, is the first thing we check is if g of x is continuous. if it's not continuous, yes, you guys are totally right, it won't be differentiable. But the reason why it wasn't differentiable is because it wasn't continuous. So that's going to be my answer. It's not continuous. Now, let's pretend we had something that was continuous. How do we check if it's differentiable? We just take the derivative. So that's very rare to get one that's not a piecewise function. But kind of maybe down here, I could think of one off the top of my head is f of x equals the cube root of x. Okay, the cube root of x is continuous. Okay, but what the cube root of x does, if you remember the graph, is it makes a vertical tangent at x equals 0. So at that vertical tangent, it's not differentiable. Now, you might remember that, you might not. So if you forgot about the graph, well, this is continuous everywhere because it's a cube root, it's an odd root. Odd roots are continuous everywhere. Even roots can only be continuous when x is greater than or equal to 0, the inside's greater than or equal to 0. So this one would have passed the first rule that it's continuous. Then the second rule we're checking, is it differentiable? And so you guys asked, how would I have done that? So we just take the derivative. So before I take the derivative, I'm going to rewrite this as x to the 1/3 power. So then I have f prime of x equals 1/3 x to the negative 2/3 power. This becomes 1 over 3 x to the 2/3, which is 1 over 3 cube root of x squared. Well, now I have a rational with a denominator, and when I set that denominator, that cannot be 0, gives me x can't be 0. Right, because I now have a denominator. The original didn't have a denominator, but the derivative did, and so that's why we got continuous but not differentiable. I highly, highly doubt the AP test would do something like this, but it is technically fair game for them to ask it. All right, 834, which of the following statements are true of the graph of f of x shown below? Number 1, there is a horizontal asymptote at y equals 0. So horizontal asymptote, yep, that is y equals 0. True. There are 3 inflection points. So inflection points are where we change from concave up to concave down or vice versa. So this graph is concave down. Then at about somewhere in here, we change to concave up. So that's 1 inflection point. Then somewhere around 0, it looks like we change back to concave down. Somewhere in there, that's a 2nd inflection point. And then over here somewhere, we change back to concave up. That's a 3rd inflection point. So yes, we do have 3 inflection points. And then there are no absolute extrema. Well, this is wrong because this guy here is an absolute minimum, and this guy there is an absolute maximum. So that's wrong. So it's just 1 and 2. Next up, 2 particles move along the x-axis, and their positions at time 0 to 2 are given by x1 equals cosine of t, and x2 equals e to the t minus 3 over 2. For how many values do the particles have the same velocity? So I want to have the same velocity. There are 2 ways to do this. The first way is to do it with the solve button, and basically set the velocity of the first particle equal to the velocity of the second particle. And the second way is to graph the 2 velocities and then just count the intersections. Both of those ways will work totally fine. So on our calculator, what that would look like is menu. Actually, before I do that, I need to get the velocities. So I'll do the derivative with respect to time of the first one was just cosine of t, and the second one was the derivative with respect to time of e to the parentheses t minus 3 over 2, and then minus 0.75. Right, that's pretty weird, but that works out, I guess. And so then we would go to Menu, Algebra, Solve, and we just want to set those two velocities equal to each other. Now, we're not going to do it for every point. We're going to do it at the interval from 0 to 2 pi, because that's what they gave me. 0, control divide, less than or equal to t, less than or equal to 2 pi. Oops, okay. This is what I did. Solve. There we are. That says times. We need this to be at. Control equals at. There we go. So now we just count, and this doesn't really work. It's giving me something funky. And so this is what I was talking about, is maybe use the solve button and it just fails. And that happens. So it failed. And then we would come back here. And I'm going to go to Menu, Actions, delete all. And Menu, Window Zoom. And I'm going to just go to our... Actually, I'm not going to go to the standard zoom. I want to go between 0 and 2 pi. Earlier, I changed my x min and x max to be -1 and +1. I'm going to put these back to like -6 and 6. I think that's around the default. Okay, so then I'm going to go to tab, and my first graph was cosine of t. I need to change that to cosine of x. But I want the derivative, right? So actually I'm going to go back and delete that because I want its derivative, right? I don't want to graph the position. I want to graph the velocity because this question said, how many times are the velocities the same? It's the derivative with respect to x of cosine of x. And then I'm going to graph the second one, which was e to the power of t minus 3, in this case x minus 3, over 2. Oh, and I need the derivative again, so I messed that up. The derivative with respect to x of e to the power of x minus 3 over 2 minus 0.75. And then I would just count how many times these intersect. I can't really tell in there. It looks a little bit weird. So maybe I'll zoom in a little bit. And the way I can do that is just shorten up the y values. You'll make this maybe be -1 or -2 and 2. And it looks like they actually don't even cross at all. So these don't touch at all in there. And so it looks like the velocities are never the same there. So my answer there would be 0. Now when I come back here, I am getting something kind of weird with this. Not quite sure why it's trying to do something, but the graph is going to be the real key where we see this and they never cross. So our answer here would be 0. All right, let me go back up here. You guys were asking about, I think, this question. Is this the graph of f or f prime? This one just said the graph of f, right? The graph of f. I know on your worksheet it might have been hard to read it, but there was no prime there. It's just the graph of f. Next one, the function f above satisfies the conclusion of Rolle's theorem because f is continuous. That's one of them, and it is. F is differentiable. Now, this is kind of tricky because at b, f is not differentiable there, right? It makes a cusp or a corner. But we don't care about at b, we care about inside, in between. Oops, my zoom just got messed up. We care about in between A and B. That's all we care about. So basically, from this point to this point in between there, it is differentiable. And f of A equals f of B, they're both 0. That's true. They don't have to be 0. They could both be 6. They could both be 4. They just need to be the same. So this is all three answers. Next up, we have a calculator question. And it asks which of the following are true about a particle that starts at time 0 and moves along a number line given by the position equals t minus 2 cubed times t minus 6. So the first question says the particle is moving to the right for t is greater than 5. How would we figure out when is it moving to the right? I want to graph its velocity. So let's go ahead and graph its velocity. So let's come back to our graphing calculator, go to actions. Let's go to delete all. And then I don't know what to make my zoom. I could go to the standard zoom, but the question talked about time 0, saying it starts there. And then choice A said time 6 or time 5, and choice B said time 2 and time 6. So one thing that I think is good to practice is you could go to the standard zoom, but you could also just say, okay, I know that we're starting at 0 and we're going up to about 6. So maybe past 6 a little bit, go to 7. And I want to go to this graph and graph the velocity. So that's the derivative of the position, which is what they gave me. So with respect to x, change all those t's to x's. So x minus 2 cubed times x minus 6. And so I have two zeros here. I'm not sure what they are. I could actually figure out what they are easily if instead of going to the window zoom, instead of counting by autos, you can actually change this to count by ones, which is kind of cool. And so then this is 1, 2, 3, 4, 5. So I know I have zeros at 2 and 5. Now, I can always do the analyze graph 0 just to make extra sure. But when I see polynomials, it's kind of nice to just count by ones. So I have a 0 at 2. And then I already know it's 5, but just to make extra sure, we have a 0 at 5. So question 1 said the particle is moving to the right for t is greater than 5. Well, yeah, the velocity is positive after 5, so that is absolutely true. Then number 2 says the particle is at rest at time 2 and time 6. This is wrong. It was time 2 and time 5. I think what they were trying to do on this question is trick people who didn't graph it, right? When you graph it, it's obvious that it's 2 and 5. But if you didn't graph it, you might have thought it was going to be 6. So that's wrong. And then the particle changes direction at time 2. Well, if we go back to our graph, we can see the particle actually doesn't change at 2. It changes at 5, but not at 2. So this one is wrong as well. So this was only number 1. Let me look back at 834, what you guys are asking about. So if 834 is the graph of f, why is there a horizontal asymptote if this is the graph of f and not f prime? Oh, just, yeah. The horizontal asymptote is, I have a lot going on here, but the graph looks like this. Now, assume there are arrows here. They should have had arrows here, but in AP Calc, a lot of times they don't put the arrows. But a horizontal asymptote is, what is this approaching? To the left and to the right. The graph, is it approaching a number or is it going off to infinity? Well, the graphs are going towards this line. What's that line? That's the x-axis, which we graph as, or write as y equals 0. So this pointing there and this pointing there, that's the horizontal asymptote. That's like a Math 3 concept that we need to make sure we remember. is the horizontal asymptote on a graph is all the way to the left, all the way to the right, and we actually don't see a horizontal asymptote on the derivative. I think what you're confusing it with is, I think you're getting confused with horizontal tangent. A horizontal tangent is not the same as a horizontal asymptote. Right? A horizontal tangent is this guy or this guy, whereas a horizontal asymptote is, if I had a graph that goes out to 2, maybe does this, that would be way on the ends. The horizontal asymptote there would be y equals 2 because the graph is approaching 2. So I think that might have been the confusion. I'm not 100% sure. But those two words always used to confuse me when I would see them. So horizontal asymptote is this graph is going way out to the right to 0, way out to the left to 0. Let f be a twice differentiable function such that when x equals c, f is decreasing, concave up, and has an x-intercept. Which of these are true? The AP test absolutely loves these questions. I see them almost once every year. These kind of ranking questions where we order 3 values. And almost always, it's going to go negative. Oh my goodness, I don't know what just happened. Negative, 0, positive, right? That would be the order if I'm ranking these, like ordering them. The negative number will always be less than the 0, which will always be less than the positive number. So they tell me, and I see I have, f, f prime, and f double prime. Those are my choices here. So I'm just going to figure out, the value. So f, let's start with f. F of x. Okay. So when I read this, it says that f is decreasing. That would be f prime is negative. Then concave up, that would be f double prime is positive. And x-intercept, that's f. F is 0. So f of x is going to be 0. And actually it's f of c, really. Let's make that into a c. F prime of c, well, it said the graph was decreasing, so that's negative. And f double prime of c, it said that the graph was concave up, that's positive. So we're going to go f prime of c, that's my negative one, is less than f of c, that's my 0, which is less than f double prime of c, that's my positive one. So I'm looking for that f prime first, then f second, and then f double prime third, choice C. Okay. Next we have a bug begins to crawl up a vertical wire. The velocity of the bug is given by this graph. So this is the graph of velocity. It says, at what time does the bug change directions? So we need to know changing directions just means that the velocity changes signs. So that happens at 6. Nice and easy. And then this one is extremely tricky. This is a very, very tough question where we have the position of a particle is given by this formula. And for what value is the speed of the particle increasing? Well, we need to remember that speed increasing occurs when the velocity and the acceleration share the same sign. This is actually a very easy question most of the time on the FRQ because they don't ask me where it's happening. They don't ask me for an interval. They just say something like, is the speed increasing or decreasing at, and then they give me a time, like at time 2. So then all I have to do is take the derivative, set it, or take the derivative and then plug in 2, and then take the derivative again for the acceleration and plug in 2, and check the signs. Unfortunately, we're not so lucky here. What we have to do here is we have to take the derivative for the velocity, and set it equal to 0. I can factor out a 6. That gives me t squared minus 8t plus 6 goes into 9 one time. And then I'm left with 3. 3 and 0 make 30. 6 goes into 35 times, so that's 15. I want two numbers that multiply to 15, add up to -8. That's -5 and -3. So you get t is 5 and t is 3. So I'm going to make a number line for v of t, and my I can put a kind of an endpoint here at 0 because it says for t is greater than 0. So I'm going to put in 3, and I'm going to put in 5. And when I make my number line, right, if I plug in like 0 or 1, we get positive. When I plug in 4 up here, actually we should do it here where it's factored. That's actually the easiest spot. Is 4 minus 5 is negative, and 4 minus 3 is positive. So I get a negative answer. You know what? I plug in 6. 6 minus 5 is positive. 6 minus 3 is positive. I get a positive answer. Now, I also need to do this for the acceleration. So I'm going to take the derivative of this up here because that looks easier. 12t minus 48 equals to 0. And I can factor it at 12. I get t minus 4 equals to 0. So I get t equals 4. Right? I could have also added 48 divided by 12. So now I'm going to make a second number line for a of t. And this happens at 4. And what I kind of want to do is I want to just make a dashed line at 4 to help me out. And in a minute I'm going to make two more, but less than 4, right? When I plug in 0 here, I get a negative. When I plug in, say, 5, I get a positive. And so then I'm going to make another dashed line at the 3 and a dashed line at the 5. And so what I can kind of see is, you know, over here on the left, v is positive and a is negative. Those are not the same signs. Here in the middle of these two dashed lines, v is negative, right, at between 3 and 5, and a is negative. Those are the same signs. That works. Then the next section, v is still negative, but now after 4, a is positive, so this did not work. And then at the very end, v is positive and a is positive. So this works. So my two sections are in between 3 and 4 worked, and then after 5 worked. So that's choice E. So a pretty tricky, kind of a really weird one to do. It's not very common, but I have seen it asked before. Right, and then now we're moving on to the Frq section. I know we did a couple of these in class. So this first one, I think a lot of you guys did in class. I think we actually did this one entirely together in class. So I'll do it very quickly for, Servando and Andrea, since they weren't here. But when is the particle moving to the left? I think Isaac as well wasn't here today. So moving to the left is v of t equal to 0. This is a non-calculator question. So I need to just take cosine of pi over 6t, set it equal to 0. Even if you don't know how to solve this, write this. This is likely 1 point, just that. Even if you don't solve it, that's a point. Now, what we're going to do is okay, when is cosine? Give me an answer of 0. Right? We talked about this in class. Is cosine gives an answer of 0 at pi over 2 and at 3 pi over 2. Right? That's 0, -1, and 0, 1. So that means that when I cross this out, I'm left with pi over 6t equals to either pi over 2 or pi over 6t equals to 3 pi over 2. Now I'm going to multiply both sides by 6 over pi to isolate for the t. This gives me t equals 6 over 2 is 3. Here, same thing, multiply by 6 over pi. Multiply by 6 over pi. Pi's cancel. 6 cancels with 2 to 3. 3 times 3 is 9. So t is 3 or t is 9. Okay, now I want when is the particle moving to the left? These are the times where we would be at rest. So I need to make a number line analysis. And we have actually two endpoints between 0 and 12. And so I'm going to put V here. So if I plug in 1, right, what we're going to look at is this: all students take calculus. If I plug in 1 into cosine of pi over 6t, that's cosine of pi over 6. That's in, pi over 6 is in this all quadrant. Cosine would be positive. If I plug in 4, 5, 6, 7, any of those, I'm going to get something in one of the next quadrants. Right, one of these quadrants. So cosine of 4 pi over 6 is cosine of 2 pi over 3. That's 1 less than the denominator. That's the sine quadrant. So we get a negative answer. If I plug in, say, 11, 10, or 11, I get like cosine of 11 pi over 6. That's 1 less than double. That's this cosine quadrant. We get positive. Now, if that was a little too hard for you, what we can do is just the first one was easy. And sine and cosine, they like 99% of the time, they always switch because it's just up, down, up, down, up, down. So this would be positive, negative, positive. All I really had to check was this guy. So when is it moving to the left is this interval. So we'd say something like V moves left, 4, 3 less than t less than 9, because V of t is less than 0 for that interval. So we had a question about this guy up here. Okay, so B says t is just greater than 4. Okay, but we didn't want greater than 4. We wanted the two sections here. I know this looks really weird. Let me see if I can draw it a little bit cleaner. Is on my V, we had in between 0 and 3, we were positive. Then from 3 to 5, we were negative. And from 5 and on, we were positive. Then for A, we just had 4. Right? We just had 4. And before 4, we were negative. After 4, we were positive. We want to have the same sign. So what I kind of do is I kind of just split up at 3, at 4, and at 5. Now, this first section is from 0 to 3. So between 0 and 3, the velocity is positive, the acceleration is negative. This does not work. Now the next section is from 3 to 4, right? From 3 to 4. The velocity up here is negative. Between 3 and 5, it's negative. So in this section, the velocity will also be negative. The acceleration is still negative, right? This negative kind of goes to 4. So my velocity is negative. My acceleration is negative. They're both negative. That's going to work. So 3 to 4 works. Okay. My next section is between 4 and 5. Okay, for 4, my velocity is still negative. But now after 4, my acceleration is positive after 4. So these are opposite signs. It doesn't work. And after 5, that's my last interval, is from 5 on. My velocity is positive and my acceleration is positive. So that's the same sign again. So t is greater than 5 works. So t greater than 4 doesn't work. Because like 4.5 wouldn't have worked. But also 3.5 does work. So it was 3 in between 3 and 4 and also greater than 5. Both of those different things work. Okay. So it is a little bit weird. If you still have issues with that or you want to go over it a little bit more, you could come to me in, during break or something and we can talk about that. All right, next up, explain why there must be a value r for 1 is less than r, less than 3, such that h of r is negative 5. So I have h of r here. We're given a formula for h. So this is going to be IVT immediately. Right? I'm given h, I want an h. That's IVT. So first thing I need to do is make sure I explain that IVT exists. Or IVT, sorry, can be applied. So we could say something like f and g are differentiable, which means they're continuous, and therefore h of x is also continuous and differentiable. So IVT applies, something like that. Okay. Now, what I want to do whenever I'm doing IVT is I need to plug in both of those endpoints. So I need to show this step, h of 1 equals, and then also h of 3 equals. So h of 1 is going to be f of g of 1 minus 6. That turns into f of g of 1 is 2 minus 6. F of 2 is 9. 9 minus 6 is 3. Then h of 3, f of g of 3 minus 6. That's f of g of 3 is 4 minus 6. F of 4 is negative 1 minus 6. We get negative 7. So is negative 5 in between 3 and negative 7? Yes, it is. So I could say, yes, there must be a r or an r for 1 less than r less than 3. I'm just going to repeat what they wrote. Such that h of r equals negative 5. And I'm going to say by IVT. Likely this is enough. But I like to say, also, oops, I don't know why that keeps happening. Because, and I would say something like, I can either say negative 7 is less than 5 is less than 3. Or if I want to, instead of saying that negative 7, I could have written h of 3 is less than 5, which is less than h of 1. And some of you even go a little bit extra and say h of 1 equals to 3 and h of 3 equals to negative 7. That's great as well. But basically you're showing that h of 3 and h of 1, 5 is in the middle of them. Then the next one, we want an h prime of c equal to a number not 0. And again, we're given h. So that's MVT. If it was equal to 0, it would have been rolls. So for B, what does MVT say? MVT says we need some f prime of c equal to f of b minus f of a over b minus a. Don't take the derivative. A couple of you guys in class tried to do h prime of x and you did chain rule and you did an awesome job and you did it right. But that's not what we're doing here. We're doing MVT, which is saying there is some h prime of c that would equal to h of b, in this case 3, minus h of 1 over 3 minus 1. We don't need to solve for it. We just need to show that it's going to be negative 5. So h prime of c, we already plugged in h of 3. When we plugged in h of 3, we got negative 7. And we also already plugged in h of 1, and we got 3 over 3 minus 1, which is negative 10 over 2, which is negative 5. That's what I wanted. So we can say, yes, there must be a value c for 1 is less than c less than 3, such that h prime of c. Now I could, if I want to really show all of my work, I could say equals h of 3 minus h of 1 over 3 minus 1, which is equal to negative 5 by MVT. Now, had I just put, h prime of c directly equal to negative 5, that would have been fine as well. Right? That's what they have up here, and that's fine. Somewhere I probably should have written that h is differentiable and continuous as well. But, I already put that in A. I forgot to rewrite it, but it would be nice. All right, next up, we have a particle, we kind of talked about this at the end of class, where if it's moving along the y-axis, then up is positive and down would be negative. And so they say, in which direction is the particle moving? So which direction is the particle moving? Remember, moving is always velocity. So we want v of 1.5. So for A, we're going to just say v of 1.5 equals, and then we're just going to plug this into our calculator. This is very easy, very quick. So v was t times, make sure you put that times, otherwise it won't come out right, sine of t squared. And then I'm plugging in, I'm not solving, I'm plugging in, time 1.5. Okay, we get 1.1671. And what I want to see right is greater than 0. So then we would say the particle is moving up at t equals 1.5 because v of 1.5 is greater than 0. That's your explanation. Then for B, it says find the acceleration at time 1.5. So I'm going to do that first. There's a period. Okay, whenever there's a period here and they say to do something, I like to just do that first and then keep going. Don't forget that there's more though. Okay. Oops. I don't think I showed this. I think I was still in the calculator, but that's what I wrote. V of 1.5 equals 1.1671, greater than 0, and then I wrote in that. So I'm going to come back here, and I want the acceleration at time 1.5. So we need to, in order to get the acceleration, we need to take the derivative with respect to t, and then I can come up here and grab this, but I need to get rid of the at t equals 1.5 because that needs to go outside of the derivative parentheses, not inside. Okay, if you put it inside, you're going to get 0. It always needs to go outside. So negative 2.0487. So coming back here, we would say that A of 1.5 equals negative 2.0487, which is less than 0. And they say, is the velocity of the particle increasing? So remember that velocity increasing means acceleration was positive. So it'd say, no, the velocity is not increasing at t equals 1.5 because A of 1.5 is less than 0. At the beginning of this problem, I know it's really hard to read. I copy-pasted this. This came out not very nice, but it tells me velocity. So they say the velocity is given. So I know that's velocity. It should have said v of t equals t sine of t squared, but I know it's just really hard to read. But they told me that that's the velocity formula. So when in A, I was just plugging it directly in, and then in B, I was taking the derivative. Next one, a particle moves along the y-axis, and again, same thing, where they give me a velocity. So again, y-axis, up positive, down negative. And then they tell us at time 0, the particle is at y equals negative 1. Find the acceleration of the particle at time 2. So A, I want A of 2. So on my calculator, I have a formula for velocity. If I want acceleration, I'm going to just take the derivative and plug in time 2. So d dt of 1 minus, I want trig inverse tan of e to the t, and actually don't do the little e there, to the actual e button, e to the t, and control equals at time 2. And I'm going to go ahead and hit control enter. Oops. I have the t first at time equals 2. There we go. So we get this 1 over, that's hyperbolic cosine. We haven't learned that. You won't learn that unless you go into some really advanced math in college, but that's hyperbolic cosine is what that is. So we get negative 0.1329 when I hit Control Enter. So this is negative 0.1329. They didn't ask me if this was, anything about positive negatives. They just asked me for the answer. B is the speed of the particle increasing or decreasing. Remember, this is always check V of 2 and check A of 2. Check both signs. So I'm going to write in V of 2 equals. Now, in order to get V of 2 on my calculator, I'm just going to pop back up here and highlight this so I can be a little bit lazy. Right, hold down Shift, select that part, hit Enter, and then I can do Control equals at time 2, and again I'll do Control Enter, and so I get negative 0.436. Oops. So negative 0.4363. That's less than 0. Then I'm going to just rewrite that A of 2, which was negative 0.1329, is also less than 0. So now I can say the speed of the particle is increasing at t equals 2 because V of 2 is less than 0 and A of 2 is less than 0. That's all I have to say. They're both less than 0. If you want to, you can write same signs. If they have the same signs, the speed is increasing. If they have opposite signs, then the speed is decreasing. And then the last question says to find the time t is greater than 0 at which the particle reaches its highest point. Initially, I'm thinking absolute max, but the problem with absolute max is I don't have an equation for position, and I would need that to be able to plug back in. So we can actually do that with an integral. We can get one with an integral, but I also don't even have an interval, right? So I could have taken an integral to get back to position, use this at time 0, y equals negative 1 to get the c, but we're not going to do that. We don't even have an interval from like a to b. They didn't give us one. So when I see maximum and I don't have an interval, that's when I take the derivative, set it to 0. But what am I taking the derivative of? Highest point means the highest position. Okay, so the derivative of position is velocity equal to 0. I already have a formula for velocity. Just writing that, by the way, got me 1 point. So I already have a formula for velocity. I'm not going to plug in 0, but I am going to set it equal to 0. Okay. So I'm going to do the solve button and set it equal to 0, or I can do the graphing calculator and show the analyze graph 0 part there. So menu, algebra, solve, and then I just want the velocity part. So 1 minus inverse tangent of e to the t equals to 0, comma t. And then I'm going to just hit Control Enter. And the only answer I get is t equals 0.443. That's it. That's all I get. So I get the number line for v of t with 0.443. And, I want to write t equals 0.433. I want to write that. Okay. So this might have been 1 point. Make sure I write it underneath and then add it to my number line. So how am I going to actually fill out my number line? I need to plug back into v. And I can't do that in my head, but it's a calculator question. So I already know that when I plugged in 2, I got a negative answer. So my guess is if I plug in something smaller than 0.4, I'm going to get a positive answer. So I'll try 0.1, and I get a positive answer. So again, I already plugged in 2, I got negative. I plug in 0.1, I get positive. So I can fill that in on my number line. First it was positive, and then we're negative. So this graph increases, then decreases. So because, this is the only time where I have anything that looks like a max, that has to be the absolute max. So we could say something like the particle reaches the highest point at time 0.443 because v of t is greater than 0 before t equals 0.443 and v of t is less than 0 after t equals 0.443. Something like that. Okay, the next question. Let f be a twice differentiable function. F of 2 equals 5, f of 5 equals 2. And we're given g of x equals f of x. Explain why. As soon as I see explain why, there must be, I'm thinking rolls, IVT, MVT, EVT. F prime of c to 1. So f prime of c, MVT are rolls because I have f, and because it's equal to a number, that's MVT. Okay, so if I'm doing MVT, what I need to always do is do f prime of c equals f of b, which in this case is 5, minus f of 2 over 5 minus 2. Well, f of 5 was 2, right? They gave that to me. And then f of 2 was 5 over 5 minus 2. That's negative 3 over positive 3, which is negative 1. So I'm going to say something like f is differentiable, therefore it's continuous. So by MVT, there must be a c for 2 less than c less than 5, such that f prime of c equals to negative 1. This is more than enough because I showed my work up here. I do need to show that work though. B says show that g prime of 2 equals g prime of 5, and then use this result to explain why there must be a k for 2 less than k less than 5, such that g double prime is 0. So g double prime, and I wanted to show that g primes were 0, or were equal to each other. So this is rolls, okay? It's rolls because when I have a derivative equal to 0, then that's rolls. So I want to first figure out g prime of x. That's what I have to do first, because I can't take g prime of 2 before I do that. And this is chain rule. The outside is f. That's f prime of the inside, f of x, times, then the derivative f of x is f prime of x. So now I'm going to do g prime of 2. That's f prime of f of 2 times f prime of 2, which is f prime of f of 2 is 5 times f prime of 2. Now, I'm like, crap, I don't know what f prime of 5 is. I don't know what f prime of 2 is. But let's just try plugging in g prime of 5 and see what happens. So g prime of 5 equals f prime of f of 5 times f prime of 5. Well, this is f prime of f of 5 was 2 times f prime of 5. And see, hey, you know what? These are the same. So g prime of 2 equals g prime of 5. So then because those are equal, I'm going to say g prime is differentiable, which makes it continuous, right? Why? Because this was twice differentiable. So we could say by rolls, there must be a k such, or for two less than k less than 5, such that g double prime of x, or we'll say k, equals 0. All right, C, show that if f double prime of x is 0, then the graph of g would not have an inflection point. So if I want the graph of g an inflection point, I need to be thinking about g double prime. I need to consider g double prime. So I have a formula for g prime of x. We wrote it up here. We want to get a formula for it, g double prime of x. This is a product rule. That's one term times another term. So the derivative of the first part, the outside, is f prime. The derivative of f prime is f double prime of f of x times the derivative of this inside is f prime of x. And times, I'm going to leave f prime of x alone. That's the first part of my product rule. Then plus, now I'm going to leave f prime of f of x alone. And times the derivative, the f prime part will be f double prime of x. Okay, so that's the derivative. And what they said is that show that if f double prime of x is equal to 0, then g wouldn't have an inflection point. So we want to set this equal to 0. That's how I solve for an inflection point. But then we're going to say if f double prime of x equals 0, then this is going to become 0 times f prime of x times f prime of x plus f prime of f of x times f double prime, we're calling 0. So it says 0 equal to 0, which is technically always true, but this isn't giving us a solution. So therefore, if f double prime of x equals 0, then g has no inflection points. Okay, because everything just went away. All right, and then D says let h of x equal f of x minus x. Explain why there must be, again, I'm thinking IVT, MVT roles, EVT even, a value r such that h of r equals 0. So h of r, and I have h. So this is IVT. Okay. So if I want to do IVT, I need to plug in 2 to h, plug in 5 to h. This is very similar to the question we did before. So for D, we're going to say h of 2 is equal to, now it's f of x minus x, so that's f of 2 minus 2. F of 2 minus 2, remember that f of 2 is 5, so that's 3. Then h of 5 is going to be f of 5 minus 2, remember that f of 5 was 2, minus x minus x. So h of 5 minus 5. So 2 minus 5 is negative 3. And they wanted some value, they're calling it r, where h of r is 0. So I'm going to just say that, h is continuous, right? It was there. And so we'll say, therefore, by IVT, there must be a value r such, or for, and we do our interval 2 less than r less than 5, such that h of r equals 0, because, negative 3 is less than 0, which is less than 3. That's fine. Okay. Where do you get that f double prime is 0 if you're supposed to plug in f, and then that is supposed to be f double prime? In this case, for C, they told me that if f double prime is 0, then show that the graph doesn't have an inflection point. So what I did is first I just took the second derivative, and then wherever I saw anything with an f double prime, we turned it to 0. And when we did that, this whole entire thing goes to 0. This whole entire thing goes to 0. It doesn't matter that I have nothing to plug in, because they're just saying that, if f double prime is always 0, right? F double prime of x equals 0 for all x. So it didn't matter. Oops. It didn't matter what was inside of it because they're saying it's always 0, right? So I do get what you're saying is like, oh, how did I know it was 0? Even if it's f double prime of f of x, not x, it doesn't matter. It's saying f double prime is 0 for all x's. For anything I plug in, I'm going to get an answer of f double prime is 0. And this one says that part B is from chapter 6, but it's okay, we can still kind of do it. So we have this graph. It's the graph of g prime, and that's the derivative. So A, find all points of inflection. Okay, and again, this is the graph of g prime. So where do I get inflection points? Inflection points would be when g prime changes between increasing and decreasing, which can also be relative maximums or minimums. So where do I get those? In between -3 and 7. I get a relative maximum at 1 and a relative minimum at 4. So let's say G has inflection points at x equals 1 and x equals 4 because G prime of x changes between increasing and decreasing, or vice versa, at those points. Right? At 1, G prime was increasing, and then we went to G prime decreasing, and at 4, we went back to G prime increasing. Okay, B, find the absolute maximum of G on the interval from -3 to 7. This one is a little bit tricky, but, and again, this is actually the next chapter, but we'll just skip ahead and kind of think about it. So how do I find an absolute maximum? I take G prime of x, set it to 0 because I want the maximum of G. And so that would be at -1, +2, and 2, 3, 4, 5, 6. So I get x equals -1, 2, and 6. And then we need to make a chart with -3, -1, 2, 6, and 7, my endpoints and my critical points. And now this part is a little bit tricky, but they started us off by saying g of 2 is 5. So I know that g of 2 is 5. How am I going to figure out g of -3? Well, g of -3 is g of 2 plus, if I want to go backwards from g prime, backwards, oops, there we go, to g, we take the integral. So plus the integral from 2 to 3, remember this goes here, -3, and this goes up there, of g prime of x dx. This is that FTC. Okay. So basically this is 5 plus, now, this is going from 2 backwards to -3. So we're going to just kind of use our geometry. But since it's going backwards, anything below is actually going to be positive. Anything above is going to be negative. This is 3 triangles. The first one has a distance of 2, a height of 4. So that's 1/2 times 2 times 4, and that's going to be positive because we're going backwards. Then minus the second one has a width of 3, 1, 2, 3, and a height of 1. And the third one, the bottom one, has a width of 2, and then a height of 2. This is 5 plus 4 minus 3/2 plus 2, that's 9, 11, minus 3/2. 11 minus 1.5 is 9.5. Now, the next one I can kind of, starting from 9.5, I can just get rid of, each time I can get rid of that area. So if I want to get rid of that area, right, this is going to be basically 9.5 And then I'm going to remove that first triangle at an area of 4. 1/2 times 2 times 4. So this is 5.5. Okay. Then at positive 2, we know the answer is 5. At 6, okay. Oh, you know what? I forgot 1. This is negative 1. Oh yeah, positive 2. This is my fault. I think I messed this up. I did mess this up because I started not at 2. I started way out here at 4, and I don't know why I did that. So this is going from 2 to negative 3. 2 is right here. So I didn't need this last triangle. So this should have been 9 minus 3/2, which is 9 minus 3/2 is 9 minus 1.5 is 7.5. Since this would have been 7.5, we're subtracting off the 4, we get 3.5. So then I know at 2, we're at 5. So at 6, to go from 2 to 6, we're going to get some negative area. That triangle is 1/2 times the width is 1, 2, 3, 4. And the height is 2. So it's a negative 4 because it's below the axis. So I'm going to take 5, subtract 4, I get 1. And 7, I'm going to add on this little triangle, 1/2 times 1 times 1, which is 0.5. We're going to add that to 1. This is 1.5. So basically, we're going to do a lot of little, areas. And just, we started off at 5, and we just kind of add or subtract based on which way we're going. Okay, again, don't worry if this is confusing. We haven't reviewed chapter 6, and we've actually never even done anything like this. This won't be on the final. Okay, but the absolute maximum in this case would be negative 7.5. C, find the average rate of change. This will be on the final of g of x for negative 3 to 7. So this would be g of 7 minus g of negative 3 over 7 minus negative 3. And actually this hard won't be because we need this. 1.5 minus 7.5 over 10. Right? I can just box that. So I got those from this, which is, I got those from the triangles. And D, find the average rate of change of g prime of x. This probably would be on the final. So g prime of x, and they wanted it from negative 3 to 7. So g prime of 7 minus g prime of negative 3 over 7 minus negative 3. Now g prime of 7 and g prime of negative 3 would be on the graph. So I'm going to clean up this graph a little bit if I can. G prime of 7 is the y value at 7, which is 1. And g prime of negative 3 is the y value there, which is negative 4. This is going to be 1 minus negative 4 over 10. That's 5 over 2, which is 1/2. And it says, does the mean value theorem guarantee or applied on the interval guarantee a value such that g double prime is equal to its average rate of change? Why or why not? We'd say MVT does not apply because g prime is not differentiable over negative 3 to 7. Right? And you could kind of add on to that, the graph of g prime has corners at negative 1, positive 1, and positive 4. so it is not differentiable. So that's all of that. Hopefully that helped out a lot. I know this one, especially part B, was a little bit weird with those triangles. But if you're still a little confused, basically the thought process here was that if we know, so if I have something like this, if I know that g of 2 is 5, oh my gosh, I hate that that keeps happening. If I know that g of 2 is 5, then basically right there, I know that my answer was 5. So anything going to the left of it, right? If I take this triangle, going to the left, up is negative, down is positive. So that little triangle would be 1/2 times 3 times 1, which is 1.5. So then I would know that g of -1, I would need to take 5 subtract 1.5, 3.5. Now g of -3, now I have this triangle. I'm still going to the left though, so because it's below, it flips because I'm going to the left. I'd add on that triangle. So that's 1/2 times 2 times 4 is the height, which is 4. So I'm going to take 3.5, add on 4, 7.5. Now going the other way to the right, starting here at 2, going to the right, below is negative. So that triangle is 1/2 times 1, 2, 3, 4, times the height is 2. 2's cancel, so I get 4 again. But now, again, where did I start this time? I started back at 2. So I'm going to take 2, and I'm going to subtract off 4. So g of, that was 6, would be 1. Okay, and then the very last one, I'd be starting here at 6, and adding on this baby triangle, which is 1/2 times 1 times 1, which is 0.5. So g of 7, I was starting at 6, which was 1, and I add on 0.5. Okay, I know it's a little bit weird, but it's basically just working that fact that the integral is the area under the curve. I have a graph of g prime. To go back to g, I take the integral to get that change. It's FTC. We're going to work on that a lot more next semester. For this semester, I will have a couple questions where you have to do some of the area stuff, but nothing like that. All right, so have a good night, guys, and I will see you tomorrow. Unless you have any questions for me, I can answer a couple questions in the next minute or two, but it is pretty late, so I do want to end this video.